Welcome back to EE Times TV. I'm Brian Fuller, Editor-in-Chief of EE Times, and with me here is Isadore Katz, EDA industry legend who was in the industry and then he was out of the industry and now he's back, and we're standing in front of his palatial CLK Design Automation meeting room
with
here.
Our outstanding graphics, which I think we did on a Etch-a-Sketch back at the office.
So this is what venture capital pays for these days. They're pretty tight, huh?
Venture capital pays for smart use of the cash that they give you before you get to give them the cash back.
Makes sense to me. So tell us about the startup. I mean, you were at Chrysalis, before that you were at Cadence, you've been around, then you were out for a while, and now you're back with CLK in this new space.
Absolutely. So I did leave EDA after Chrysalis and our merger with Invanti. Tried some different things, went into optical components, which may have not been a great idea. Nothing quite like joining an industry when the market is collapsing. And then started looking at different applications and thought of some things, and we had a brilliant business plan, and the VC that we were talking to looked at it and said, brilliant, I won't fund this ever. But if you could find something interesting to do in EDA again, we hear all about this nanometer stuff, we'll give you money. So we said, okay, that's a good offer. So we started calling our old customers. And we talked to them and said, what could you do? What do you want? What are your top issues? And we also wanted to make sure had moved to the Boston area to do Chrysalis, and we wanted to make sure we had a problem that we could solve locally. And interestingly enough, right at the top of the list was timing. They had some tools that were great in their day, but they had run out of gas. And they said, look, we need a new tool here. If you built it, we'll buy it. And we said, okay, do you need some of the new algorithms, statistical, this, that, and the other thing? And they said, maybe, later. Right now what we need is what we're doing right now, but done just a lot better and a lot more effectively. Cool. So I said, okay, we know what the problem is. We know what the opportunity is. Now let's go build a team. So we recruited our old VP of Engineering from Chrysalis, Lila France. We recruited one of the top architects from on VCS and going back to Cadence Berkeley Labs, a guy named Dr. Joe Giada, and then we started looking for talent. Now, that was in the summer of '04. The VC that we'd been talking to, which is Atlas, said, great, let's find another investor. By January of 2005, we had money in the bank and we were off the races. Now, in between there and then, I was sitting around one day trying to think of what do we call ourselves, and I went, okay, Conklin, LaFrance, Katz, and Giada. Good, CLKDA. Boom, done. And that's how we came up with the name. So really, technically, we're Cluck Duh. And it turned out the 5 letters were available on the web, and that's how we go from there. Very carefully thought through. But then we brought in more talent. We brought in a guy from Intel who'd done a number of their timing tools on the Alpha and the EVDO project. We brought in a signal integrity expert who'd worked on Freescale signal integrity tools. We recruited Dwayne Bonning and David Blau in as academic advisors, one from MIT, one from Michigan. They do real work with us and spend time with us on algorithms. And we filled out the team with really top-notch developers. But most importantly, we went back to the original partner that we'd had at the beginning and said, we're ready to go. Work with us. And they did. It'd be great if we can name them right now. We can't, but they're actually using us in production right now in 45 nanometer design. And they've been giving us specs, requirements, designs, and everything we need to do to build the next generation timing tool and signal integrity tool. That's what we are, and that's what we've done.
So talk a little bit about the competitive space. You guys aren't the only ones trying to attack this major problem.
No, I mean, and there's an incumbent tool, which is Primetime and Primetime SI, which without a doubt is one of the best tools Synopsys has ever developed, and probably one of the best tools that we've ever seen in the industry. It is the industry standard. But we know that there are times when great tools run out of gas. There are things that happen where the software architecture doesn't carry forward, or where, as importantly, there are big computing changes. So, if you look back over history, a lot of times those computing changes have been the things that drove the big industrial shifts. So, I go back to Daisy Systems, in which I worked on, these strange little black boxes with, our own proprietary operating systems, DNix, which was just like Unix, only different. And, and that gave way to Suns and Apollos, which then gave way to, Linux, et cetera. Now, one of the things that Dr. Giada brought to the table is that his PhD is from the University of Newcastle in the UK, where he specifically had studied threaded architectures. And he looked at this problem and said, I think I can figure out how to design an architecture, not an algorithm, an architecture that enables us to thread a very difficult problem, which is signal integrity. And that's been the focus of the system. So in the competitive space, you look for those discontinuities, things that are going to essentially leave the existing technology in the dust because they aren't going to move forward on the next 2 process nodes. One of the things we have to do in EDA is we've got to keep scaling. Our customers don't stop to design smaller chips. So we have to keep growing. Well, one of the things we do know is that processors aren't getting any faster. We've heard this at DAC presentations and keynote speeches. Don't look for a 560 gigahertz processor. Look for more processors. So what João and the team sat down to do, and along with Lee, is let's design an architecture that enables us for this class of problems to thread, and thread really efficiently. And that was one part. And as they looked at it, they said, this threading, not only does it let us do one job much faster, if we could also use that same architecture to let us do a really true incremental, where you get the same answer whether you ran the whole design or just part of the design, and the size of the change was scaled to the problem, now we've really got it. And that's what we've pulled off. Now, if you don't begin with that game plan in mind from day 0, you can't retrofit it. It's very hard to go back and look at an existing tool and say, let's make it threaded or let's make it incremental. We all went through tools that were designed to be batch tools, and then someone said, let's have an interactive layer on top. And just horrible Franken tools come out of that. Piece of this attached to a piece of that, and it's not pretty. So what use really is a ground up type development.